So here with question 7, we're asked to solve the equation using the quadratic formula. And I went ahead and I put the quadratic formula over here for us. So we have x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. And what we're going to do is we're given the equation 3 equals negative 12 over x minus 2 over x squared. And we really want to go ahead and take our given equation and somehow manipulate it so that we can end up with some ax squared plus bx plus c equals 0. This is standard form for a quadratic equation. And the reason that we want to put our given equation into this form is so that we can easily identify our a, b, and c, because those are the values that we need to take and then plug into the quadratic equation to solve for x. Right now, it doesn't quite look like we have those values, right? Because certainly we have an x squared in the denominator of a fraction. We have an x in the bottom in the denominator of a fraction. So we've got some work to do in order to manipulate our given equation to look more like this, standard form. And if we want to go ahead and get our a, b, and c, let's get rid of these fractions first. Let's go ahead and clear the fraction. And to do that, we'll want to multiply this entire equation by the common denominator. And if we take a look, we have x squared, x, and if you want to, you can help, or rather you can write 3 over 1 if that helps you to visualize all 3 of our denominators here. And if you take a look, it's easy to see that our common denominator here is going to be x squared. So let's multiply each term in this equation by x squared. And another way to say that is just multiply the whole equation by x squared. So I'm going to rewrite the given equation one more time down here before we actually do any multiplying. All right. And so, like we just said, we're going to multiply each term in the given equation by x squared. That's our common denominator. And I like to write the term that we're multiplying by above each of the original terms. And so now what we're going to end up with is here on the left, we're going to have x squared times 3, which gives us 3x squared, equals, and now here, this single x is going to cancel out with one of the x's that we're multiplying by, which is going to leave us with a single x times negative 12, so that gives us negative 12x, and then minus from the original equation. And here, x squared is going to cancel with x squared, and we're left with just our 2. And so now this is certainly looking a lot better than what we started with, right? No equation, or no fractions rather. And now if we want to go ahead and get this into standard form, meaning we have our x squared, the x, and the constant on one side of the equal sign, then all we have to do is add 12x to both sides, add this 2 to both sides, and I think we'll be in pretty good shape. And when we do that, we end up with 3x squared plus 12x plus 2 equals 0. And now this looks an awful lot like our given, or rather our standard form for a quadratic equation. We can easily identify a, we can easily identify b, and we can easily identify c. Don't forget, when you're identifying your a, b, and c, to also include whatever sign accompanies that particular value. So if this was 3x squared minus 12, our b would be negative 12. If this was minus 2, our c would be negative 2, and so on. In this case, though, we have a equals 3, b equals positive 12, and c equals positive 2. So now we're going to take these values, plug them into the quadratic equation, and see what happens. So we have x equals negative b plus and minus the square root of b squared minus 4ac all over 2 times a. And you'll notice that Really, you should use parentheses anytime you're plugging in values for variables, but you'll notice here I used parentheses every time I plugged in a value for A, B, or C. And it just makes sure that you're careful with your signs, because if we had negatives here, if you don't include the parentheses, sometimes you're liable to make a little mistake, and we don't want that to happen. And if you include parentheses, it does tend to cut down on little sign errors. All right, let's go through and clean this up a little bit. So we have this negative. If we distribute, we'll end up with a negative 12 plus and minus the square root of, well, let's see, 12 squared is positive 144. And here we have negative 4 times 3 is negative 12, and negative 12 times 2 is minus 24. All over 2 times 3 gives us 6. Again, let's go ahead and simplify a little bit. We have negative 12 plus and minus the square root of, well, 144 minus 24 gives us 120 all over 6. And I'm going to make some room over here. I'm going to get rid of all of this. So hopefully you have that written down. If not, just rewind. That's the beauty of YouTube. All right, so we'll go up here. So I'm just going to rewrite this. So we have x equals negative 12 plus and minus radical 120 over 6. All right, well, I think we can go ahead and break down this radical 12, or 100 rather, and 20. We can break this down, right? So we're looking for, I do good stuff, bad stuff, meaning I like to find what is the largest perfect square inside 120 that we multiply by something else to give us 120. So let's see, I think the largest perfect square is going to be 4 times 30, right? Gives us 120. And the reason I like to break it down like this is because now that I see what the largest perfect square times some other number to give us 120 is, I know this perfect square will be able to come out nice, free, and clear from the radical. And I think that'll make a little more sense here in a second. So we end up with negative 12 plus and minus. Well, we just broke down this radical 120 into radical 4 times radical 30, but we know radical 4 evaluates to 2. And then we have the radical 30 divided by 6. And now you'll notice that when these three numbers can all be reduced, you should reduce them. Notice it creates kind of like a little triangle here. So when all three of these numbers can be reduced by something that's common, other than 1, of course, you really want to do that. And if we have a 2, a negative 12, and a 6, it looks like we can reduce all three of these by at least a factor of 2, right? So 2 goes into itself once, 2 goes into negative 12, negative 6 times, and 2 goes into 6 3 times. And so when we make that reduction there, we end up, our final answer being negative 6 plus and minus radical 30 over 3. And there we have our solution to number 7. So again, even though I erased it, I'll verbally go through it again. We took our given equation, we wanted to clear the fraction so that we could put our given equation into standard form. So we multiplied each term by x squared. That allowed us to clear the fraction and put the equation into standard form, where we were able to easily identify our a, b, and c. We took those a, b, and c values, plugged it into the quadratic formula, evaluated. We broke down our radical 120 into radical 4, a perfect square, times radical 30. Can't break down 30. And so when we evaluated, we ended up with negative 6 plus and minus radical 30 over 3.